Welcome to this talk on Gradle. I want to show you some of the latest features that might be helpful for you, and we'll talk about roadmap for the Gradle Android plugin. So let's get started. Who of you work with more than one repository, usually? Right. Okay. So, and I want to show you a new feature in Gradle that makes this much easier. Okay, so let's make this. Can you see that in the last row? Okay, so what I have here is a repository, my app, right? It's in this case, it's a Java app. It could be an Android app. And when you look at the build file, what you can see it depends on some libraries, right? For example, number utils and string utils. And they are provided by another repository. But this repository has a binary dependencies on those, right? Okay, so far so good. So let's tell Gradle, hey, run this Java app. And what we can see is the binaries haven't been published to this to any repository I'm connected with, to any binary repository I'm connected with. Okay, so what I could do now, right? Here I have the my utils repository, just to give you a quick insight into this, right? And this has the numbers utils classes and the string utils classes that I use in my app repository. So what I could do now, I could, for example, publish them to a local repository or publish them to a remote repository, then consume them in my app. When I need to change them, I need to go back to my utils, and so on and so on. Okay, but what you can now do in Gradle is the following. You can simply say Gradle Gradle include build my utils, and then you just say run. And Gradle automatically now replaces the binary, the external dependencies you have, with the output of my utils. Does this make sense? What is happening? Right? So, and that's pretty cool, right? It's on the command line. You can say, hey, don't use any binary dependencies, use the other repository, and all the orchestration you don't have to deal with, right? So when you look at my app, what you can see is, if you look in the main class, there is still a lot of red, right? There's strings, there's numbers. Well, of course, because the binary dependencies have not been resolved, right? And so that's why IntelliJ can't work with those, right? Plus, even if the binary dependencies were resolved, there would be no way you can work on the sources of those, right? So what you can now easily do is that you tell Gradle, hey, please treat them as one build, as one thing also in IntelliJ, right? So and if you now look in IntelliJ, ask for an update, and boom, you now have my app and my utils connected in the IDE, including source code navigation, right? And you could now change the code. Oops, that was the wrong one. You can now, no, let me go somewhere else. My utils, number utils, source, numbers, and you just say this, and you can then say Gradle run, and the result is no longer 42. Oops, I forgot the include. And it's a good, almost by design, because the problem with this approach is you have to remember all the time, right, to add it to the command line that you want to include this other repository, right? But you see, the answer is 437. How inconvenient would it be to always go to the other build, publish to a local repository, go back. You don't have source code navigation in the IDE. So extremely helpful, but we can do, this is kind of an ad hoc way to integrate, right, on the command line with the include build feature. What you can do alternatively is that you go into the settings.gradle file and say, that's the wrong one, this one here, that you say something like include builds my utils. And then, oops, that's of course. And then you don't need to specify this on a command line anymore. Then you can just say Gradle run, and things should just work. Could not find include builds. Let me quickly check something. Include build. I'm sorry. So now you tell Gradle, treat them as one composite, right? And you can now say Gradle run, and now my utils binaries will always be replaced with the local repository and the output of those, right? So, but you might say, hey, I don't want to touch the build of my app. Sometimes I want to work on both repositories, my app and my util, right, on the source code. And sometimes I only want to work with my app, and I want to actually depend on the binaries. So, and that brings us to the next option that you have. I have here a directory I call composite. And when you open this up, let's try this again. When you open this, you see this composite directory has only two files, a build.gradle and a settings.gradle. And in the settings.gradle, we just say, hey, include two builds, my app and my utils, right? And those are two completely separate Gradle builds. They can even be built by different Gradle versions, right? No problem. And the composite project is basically a synthetic project that defines the composite of those two repositories you want to work with, right? And there's another thing. If you look at the build.gradle file, what you can see is that in the composite project, we define surrogate tasks. We define a run task that depends on the my app run task. We define a check all task that depend on the various check tasks of the different repo builds, right? So, and you can now easily do that, and all the dependencies and all the orchestration is done by Gradle, right? So if you now say here, run, right? You see my utils is built and my app is built, and you can now have as many composites of different repository combinations you want to work with as you want. So there's one thing that is still inconvenient, and we're working on that. It's this build.gradle file here, where you have manually create those synthetic tasks, right, that combine the two repositories on an execution level. So what we will be working on, and I think it will be a part of Gradle 3.3, is that the only thing you need to do is to define the settings.gradle and the composites, right? And then you will be able to do things like Gradle my app run, and Gradle will figure out the rest. That makes sense, right? So, yeah, very powerful way to deal with multiple repositories. Okay. Next topic. Don't need to go in full screen mode. Kotlin support. Who of you is using Kotlin? And I think it's a growing number in the Android world. So who of you have heard that Gradle is will be supporting Kotlin as a first-class build language to write your build scripts with? Yes. So Ty, I don't know, Ty, are you here? He is giving a talk fully dedicated to how to work with Gradle and Kotlin. I'm not sure today or tomorrow. So I don't want to go into every detail of that. I just want to give you a quick demo of how this already looks like. So what you can see here, this is a Hello Android project, and the build.gradle file is empty, but there is a build.gradle.kts file that is not empty. And and it looks pretty similar to what you are used to from a build.gradle file, but if you look at the details, it's this is Kotlin, right? This is not Groovy. And one thing you get out from the move to Kotlin is better IDE support. It's a key reason why we're doing this, right? You can, right, you have full build tools version, full content assist, right, for all the options that you have, right? And that is, right, so don't need to, much less copy and paste, much less need to go to the Gradle reference documentation, right? Finally, right? So I know everyone is waiting for that. With a dynamic language, that is much harder to do. So with a statically typed language, that is at the same time very DSL friendly, that is now a possibility. And we cooperate closely with the JetBrains folks to enable that. And just to give you a feeling that this is real, right? I can run this, hopefully, Gradle build, Gradle Android build defined by Kotlin, right? So you can use that. It's the Kotlin supported at version 0.3.2, so there's still things we want to do to make the DSL more convenient, right? But just one of the power features. So let's say you wanna apply an external plugin, right? So I have already prepared that. So you would add, this is the Gradle Git plugin from Andrew Oberstar. So the moment you add that to your build script class path, you now have, in the background, this plugin is now automatically downloaded and you have content assist. So you can apply that. So let's say I want to use the GitHub Pages plugin, right? So I have, and I can now say configure GitHub Pages plugin extension, and this is for publishing GitHub pages via Gradle, right? I can now say what, and I, so what are my configuration options? Oops, something is wrong. Set repo, and you see, I mean, it's what you would expect, right? When writing Android or Java code, you now have that in your build. So we are very excited about this, and just want to talk quickly about all the reasons why we made that move, basically. So first of all, Kotlin is statically typed at its core, right? And at the same time, extremely convenient, right? Without all the boilerplate you have in Java. That means it is still a very elegant DSL, but it's statically typed, which means much better IDE support and also better performance. Especially when you write your plugins in dynamic Groovy, this can have a negative effect on your performance. The alternative at the moment is to write it in Java, which is not a very friendly way to write a Gradle plugin. So, and Kotlin is now the ideal compromise, right? Great IDE support, very DSL friendly. Kotlin is a great language in general, right? And the great thing as well is, especially in the Android world, so many people use it already for Android application development, so there's now only one language you need to learn, right? Not that you need to have a deep Groovy understanding to work with Gradle, but still, it's different syntax, so I think that, especially for Android, that move makes a lot of sense, right? And plus, we have a close partnership with JetBrains, so there's a great engineering team there with whom we collaborate closely to make that a great IDE experience. Okay. Next topic. So performance is a very important topic for build systems, and one thing we're working on intensely is to improve the caching, right? And I want to talk about that in a little bit more detail. So yeah, caching, not repeating work already done. Predexing libraries, for example, right? So in Gradle, if you look at Gradle, our executional units are tasks, right? And tasks have inputs and outputs, and we have a rich model in Gradle to declare those. An input can be a property, source compatibility, it's the sources, right? It's the class path, and the output is, in the case of a compiled task, is the classes directory. Okay. So, and that is all well defined in Gradle land, right? And that is why you have up-to-date builds. And I don't know who of you have ever written a custom task in Gradle. Task authors can use annotations to declare the input and the output of a task, right? So, and what Gradle does already for you, right? It checks, have the input changed and have the output changed. And if none of them have changed, the task is considered up to date and is not executed. Otherwise, it's executed, right? You know that from the up-to-date messages on your console output or in Android Studio. So, and that is what we call incremental builds. It's now getting interesting. So, incremental builds work in a way all content is the same as last time when we ran this build on this machine. Then nothing is done, right? Only then. So, and incremental build must not be confused with incremental task. I give you an example. In Android, the Java compile task is incremental. You can enable incremental compile, and that is another that is on a different level. So this works that the task basically asks Gradle, hey, tell me the files that have changed. I don't have to redo everything. I know from my domain, in this case the Java compile domain, I know how I can rebuild only the stuff effectively that has changed, right? Some tasks can be incremental, some other tasks cannot be incremental. Java doc cannot be incremental, right? If anything changes, you have to regenerate the whole Java doc, right? So those are incremental tasks, but we're talking here about incremental builds, right? That is a level higher. That means when something has changed, we execute it. If not, we don't. Okay, so let's look at a typical use case. Who of you is working, let's say, on a daily basis with multiple branches? Right. Okay. So then you will probably know the following scenario, right? So okay. So I'm just checking out so public repository Gradle task cache demo, right? And it's a Gradle build. And it has only one class, a main class, right? And what we do now, we build it. Okay? So, and you can see the classes have been compiled, the jar has been built. Okay. So the build had to take actions because it was a fresh checkout, right? There was nothing, nothing cached before, so we had to build it. Okay. So if we now switching out, if we now switching to another branch, feature X, let's look if the task is different. Yes, the main class is different. So if we now say Gradle build, again, of course, we have to recompile and rebuild the jar. Makes sense, right? This is fine, but when we now go back to master and we build again, we had to recompile again because Gradle, the incremental build of Gradle, only remembers the last build. So when you switch between branches, you always have to do a rebuild. Although we had built that before on this local machine, but this has gone after the switch to another branch. So who of you is affected by that? Who of you was frustrated by that you had to rebuild after switching between branches? Okay. That's good. No, it's important to know. Good. So, and we have to recompile again. Yes. Sad panda. So we're using results from last time when we ran this build on this machine. We can do better, right? Why not from any time before when we ran this build on this machine? This is the next step for our caching, right? And I want to show you a demo for this. It still have to enable a feature toggle, right? Org Gradle cache task true. And we built the whole thing, right? The master branch. We're now going to the feature X branch. We built it, fine. It was the first build of that feature branch, so we had to compile it. But now, could you see that? Now we went back to the master branch again, and the results are now loaded from our new task output cache. So we now basically store all the output across all your builds, right? Locally. So this cache works the following, right? If there's we for every task we calculate a key that describes exactly the inputs of that task, including the tool chain that is used, etc. Right? And when the output for this key is in the cache, when it's not in the cache, we execute and we put the output in the cache, right? And if it has a match, we load the output from the cache and copy it in your build output directory. Okay, so that's good. So at the moment, yeah, the current, I think it's a less common scenario. The current Gradle up-to-date cache, when you have multiple directories with the same project, the cache is also not reused, right? If you would check out 2 times the same project into different directories, and you build it in one directory, and then you run the build in the other directory, the output is not reused. With this local cache, that will no longer be the case. The output will be reused, which is not completely trivial because you have to deal with absolute and relative paths, right? It's you have to do this properly, right? Okay, so and where it gets also very interesting, right, is why just on this machine, right? So who of you work in teams with more than 10 people? So, and I'm sure every one of you is using some CI solution for your Android build, right? So, and that is the next thing I want to demo to you. Upsala, the font sizes. Do you have good eyes in the last row? Sorry, it's a pre-recorded demo in this case. So what we also have available is a shared or a distributed cache, right? That we are firing up here, right? We're firing up a virtual machine with a distributed cache, and what we're now doing is we're running a Gradle build, right, of our cache demo project, and now we're going into in this case it's virtual, but we switch to a Linux image and build the same project, and it also connects with our distributed cache, and you can see the output was loaded from the distributed cache, right? So now you have output that is shared between machines, right? And the primary source for filling the cache is usually the CI machine, and the primary consumers are the developers. That's how it usually. Peer-to-peer scenarios are also possible, but they can introduce fragility, right? Because you might run the build, and at the same time you might start changing your code, and so the typical setup is that CI fills it, developer consume it, right? And that would include things like predex libraries, etc., right? There's a lot of expensive to create input in the Android world, and if that can be shared, I think that's extremely valuable for your build time. Okay, so we have a machine local cache, and we have a cache that is centralized, where we recommend that only CI pushes into that cache. So it's still experimental, but it's available, right? At the moment, it's only pre-configured for Java tasks. Android will be next. We don't have any sophisticated cache management yet. So, for example, your local cache, we don't have any. You have to delete it at one point when it grows too big, right? So that is still stuff. Diagnostics we're improving. It's also not hardened yet by significant production usage, but that will change very soon. We have many large enterprises that use Gradle on this Java side with 2,000 engineers, right, working on one project. For them, a distributed cache is like, I mean, the leverage is dramatic. So that will pretty soon be hardened, and we expect it to be production ready end of Q4. And of course, you can configure it for any of your custom tasks, right? Whatever you're doing, it's open, right? You just have to. The good thing, what the distributed cache is doing, or the task local cache, you should never be required to do a clean of that cache, right? That means that the input and the output have to be properly defined, right? You can't, when your task make implicit assumptions, for example, oh, I just grab whatever version of Java is on my machine, then it's not part of the key, and then the cache becomes unreliable, right? So that is why you have to opt in with your custom task into that cache, right? Otherwise, you still can use the incremental cache that gets destroyed when you do a Gradle clean, but obviously the task output cache will not be destroyed by a clean. That's the whole point of it, right? But that's why it's opt in. We want to make sure that we reflect on the requirement that you really need to properly specify all the inputs that are relevant, which is a good discipline anyhow, because it encourages reproducible builds, right? Okay, so reliability is king, right? False negatives affect performance, like verbose equals true should not be part of the key, right, for the output of the task. Whether the logging is verbose or not verbose while creating the output of the task shouldn't matter for the actual output, right? And false positives obviously affect correctness, right? Can corrupt other builds, can corrupt future builds. So that is the most important thing to avoid. Okay. So I saw the presentation before, and the speaker mentioned performance, right, of Gradle, that it's not very fast, right? So Android performance is an interesting animal. Often it is just under the umbrella of Gradle, but when you look at it, it's four pieces, right? It's Android Studio, it's the Gradle Android plugin, it's Gradle, and it's the Android tooling, the DexIng, or the Java tooling, Java C, right? So and when you look at performance, it's the interaction of the whole tool chain. You shouldn't care too much about it. You just want to have fast builds. But as a representative of Gradle, I just want to. I mean, when Java C takes 30 seconds, right? We're not rewriting the Java compiler, right? We rely on certain parts of the tool chain. It's not the job of the build tool to make that faster, right? Dexing was for a long time a big time consumer. The Android team made it much faster with the in-process dexing. Who of you is using in-process dexing already? Big difference, isn't it? Yeah. Who of you is not aware of in-process dexing? And the rest is happy with the build time, it looks like. Okay. Performance is a key focus for us and for the Android team, for everyone, I would say, right? That's if you look just from 2.14 to 3.1, we have the largest Android build we saw out in the live, right? Where I think 100 plus developers work on, right? Hundreds of submodules. We were able to kind of model a test build according to that complexity, right? And when you do a Gradle help is an approximation of Gradle configuration time, just between 2.14 and 3.1. Within 2 months, we got that down from 6.9 to 3.4 seconds. And with 2.4, it was definitely longer than 10 seconds. It's hard, because of compatibility reasons, to go that far back with a specific Android build, but just to give you an idea. And the Android sync, in terms of on the side of what Gradle has to do, went down from 12.5 to 6.8, and that is the biggest Android build, right? That is out there. So things are improving significantly, right? So especially Android sync for many of you, and we heard that feedback, was cut in half with the release of 2.2.0, Android Studio, the Gradle Android plugin 2.2.0, and Gradle 3.1. So a lot is happening, right? And also for Java, configuration time has been extremely improved already with 2.14, and writing plugins in a static language has also very strong effect. So we're tackling this issue from many sides, right? So, and it's all about basically doing less, right? I will explain that. More caching, we talked about that. More fine-grained parallelization. So when you, at the moment, when you run an Android build in parallel with Gradle, you see a lot of waiting. You see a lot of cores waiting for some other work to be done, right? And a pretty low utilization, of course. And that is something we will be working intensely on over the next couple of months, right? And then further low-level optimizations, as you have seen with the configuration time, right? So without going into all the details, so one thing, for example, we're doing at the moment, the Gradle dependency management system at the moment only works with archive files. So you can't depend on directories. That is, when you have dependencies on Android libraries, on AARs, from one subproject to the other, you always have to build the archive, then the project consumes it, and has to unpack it again. That makes sense what I'm saying, right? So that is something we want to completely avoid. The other thing we want to avoid, if you don't depend on a full AAR, just on the classes of that AAR, don't even produce the other stuff, just to satisfy the dependency. So there's a lot in the doing less area that we can do, right? We can do caching. We talked about the distributed cache. Dependency graph caching is something we're working on. Parallel dependency resolution is something that will happen in the next 2 months. A global parallel scheduler is an important thing. So at the moment, what we don't provide, let's say if you write a task foo, right, and you want to do stuff in parallel, you cannot ask Gradle, hey, how many cores, how many processors should I use, right? Because when you run a Gradle build in parallel, right, Gradle should tell you, hey, I'm using already so many, so there are only so and so many left for you, right? So that is something we're working on, a parallel scheduler and parallel sub-project configuration to get the configuration time even more down, parallel task execution. So all stuff we work on with a big team, so you can expect with every Gradle release significant performance improvements over the next 6 months, right? We will have probably 3 releases over that time, and every release will be faster than the one before, significantly faster. That's I'm very confident about that. So would you consider performance your biggest pain point with the Android toolchain? For whom is that the biggest pain point? What other pain points are, if you have bigger ones? None? No, it's good. I mean, I think the toolchain is in many ways pretty amazing, right? And very innovative. So, okay, cool. So there's one more thing I want to show you. There's a new feature in Gradle. It's called Gradle Cloud Services and Build Scans, and I just want to demo this to you. So we have here one of our test builds, Performance Android Medium. It's actually, so we find basically small, medium, and large Android apps in the wild and use them for our automatic performance testing, right? And the Performance Android Medium is actually the WordPress application. Let's do the following. Let's build this application with -d scan enabled. And when you run this with -d scan, oops, why is it? I thought I run it before and everything is cached. Now I have to fill the time it takes. Oops, that's a good break because I need to do something for my battery. Yeah, one thing regarding performance while I'm waiting for this build. One thing with the Java-C compile that is something we're not exactly sure how we will address that is that incremental Java compile is now, when you do instant run, is now often the biggest bottleneck, right? So we're talking with an organization, they have 500,000 lines of Java code, right, in one sub-project, just the way it is. And it's not easy to change because cyclic package dependency is not like, oh, just break it down, right? That's not trivial. Once you are in that situation, it's not that easy to get out of it, right? So when they do a compile, just the Java-C compile takes them 30 seconds. So when they're doing instant run, right, and they change one line of Java without an incremental Java compile, it's 30 seconds. So for them, incremental Java compile is super important. The problem is with the incremental Java compile that it gets disabled when you use annotation processors, right? Because out of the box, there's no way for us to figure out what are those annotation processors doing. When the input changes, what effect does it have on the output, right? Annotation processors can have many degrees of freedom, right, that we don't understand and cannot heuristically in any form derive. So that is something, and many Android applications use annotation processors, so that's something we still contemplating what we do about that, right? Whether we implement incremental compile specifically for the most common annotation processors, that we have to see. The best would be if they could provide it. So, but that's one of the, considering that this is now often, when you do in-process DEXing, that now Java-C is often a bottleneck. Who would have thought that 1 year ago, right? It's something we need to address in some form. In any case, right, this build has taken 2 minutes and 10 seconds, and what you see now at the end of the build is this URL. And that is what we call a build scan. And you can click this URL, and you see now this is the output from that build, right? You can see, if you want, you can see the console output. You see the Gradle version, the Android Gradle plugin version that was used. You want to dive deep into the performance. You can see, okay, how long did the configuration take? 5 seconds, right? And then you can see, okay, the configuration of your actual build scripts, probably 2.5 seconds, and the rest is Android plugin specific stuff. You can see how long the dependency resolution took, not very long, right? You can see, task execution. You can order it by subproject. You get daemon information, right? So how old is this daemon? How many builds have been run by that daemon? And certain settings and suggestions, right? So you can see the plugins that have been applied to that project, Gradle plugins, right? And how was Gradle configured? How was the infrastructure? How many cores? What was the memory? And one use case we see, it's so hard to communicate when you have a build problem, right? When you need to ask for help. The person saying, oh, what are your properties? Do you have the daemon enabled? Can you run in debug mode? Can you send me the dependencies report? Can you check your .gradle properties file? What are your JVM arguments? I mean, it's a complete pain in the neck, right? So, and with build scans, you can now easily create such a build scan, and you can share the URL. It has deep links even, right? So you can not even, it has deep links, right? So you can just go to every aspect of the build scan and share that specific aspect, right? So, and there's something else that is pretty cool that I want to show you. It's even extendable. Let me see. Let's go to this app. Is that the right one? No. It's this guy here. So, so build scans are enabled by a Gradle plugin, the Gradle build scan plugin, right? And what you can do is you can add custom tags, right? Like Droidcon NYC, you can add custom links, or you can say after evaluate, Gradle add a custom value with the number of tasks, right? So, and when you run this build now, oops, yeah, that's not good. You can see now it's now tagged Droidcon New York, right? This is the Droidcon website, and custom value is the number of tasks, 431. If you work for Trump Plaza, you probably have to put in body weight of the developer, but that's. So that's very powerful for gathering metrics, right? And use that to communicate certain things for your developers. I want to show you a couple of other examples of build scans. At the moment, Android tests are not captured. We are working hard on that. At the moment, only JUnit tests are captured, right? But including the test output. So if you have a failing test, right, you can simply, we capture the whole output of this failing test, and you can easily share and reason with someone about that. Another thing, of course, that is captured are dependencies, right? And with a very fast and powerful search. Talked about performance, we talked about plugins. So what I can't show you right now is the other thing you can do with build scans is, and that's not available yet in the hosted offering. It's only available in the on-premises offering. That's why I can't show you out of the box, is that you can do analytics over all your builds, right? And search over them. So you can say, hey, show me, show me all the builds that have run this task and sort according to duration. to understand, is the build in India faster or slower than the build in America? When you have distributed teams, to understand if anything else, maybe the Gradle version or the Android plugin version affects the performance. So there's very, very powerful data in those builds that are waiting to be analyzed to make developers more productive, right? And I want to show you one more thing. Custom values. Not sure if I find this now. Give me 1 second. That's the last thing I want to show. Custom tags. So we want to make that a first-class citizen soon, right? All the information from version control, but with custom value, you can say this was a local build and it was dirty, right? So it was not run against a published commit. It was not pushed yet, those changes, right? And then you can publish Git information, you can publish Git status. So this is a really nice toolkit. So even stuff that we haven't done yet, that we want to make a default thing in Gradle build scans, you can easily add that via custom values. And it makes it so much easier to reason about what happened during a build, right? The other next big feature that is coming is comparison. Why did the build succeeded locally but failed on CI, right? What are you doing now? You go to Jenkins or whatever you're using, go to the console output and try to somehow reason about what happened, but it's not easy. Okay. Oh. Yeah, thanks. Okay. Yeah, that's it. Thank you. Any questions?